In sections 1.2 and 1.3, we're going to talk about congruent segments and midpoint. We will be able to find the midpoint of a segment in the coordinate plane and also find an endpoint given a midpoint and another endpoint of a segment. We will copy and bisect segments using a compass and a straight edge. First, let's talk about congruent segments. These are segments that have the same length. If we measured these segments, segment EF and GH, on your paper, they would maybe measure 3 centimeters. And we might measure this and see it's also 3 centimeters. We can write that like this: EF equals 3 centimeters, meaning the segment that joins points E to F is equal to 3 centimeters long. GH also equals 3 centimeters. Since they have the same length, we can show that those lengths are equal. EF equals GH. Remember, this means therefore EF equals GH. This is saying that the lengths are equal. And then what that tells us, because the lengths are equal, then the segments are congruent. Segment EF is congruent to segment GH. Those symbols are telling us that the segments are congruent. The way to mark that the segments are congruent are with hash marks. We might put a hash mark through there and a similar hash mark through the other one. The same type of hash mark means that that segment is congruent to that segment. Now, the segments don't have to be separate to be congruent. In this picture, if B is right in the middle, then segment AB might be congruent to segment BC. I could write it this way: segment AB is congruent to segment BC. What that means, since B is separating, dividing it into 2 congruent segments, is that in conclusion, B is called the midpoint of segment AC. Let's talk more about what a midpoint of a segment is. Now, a midpoint has to be a point. The midpoint divides the segment into 2 congruent parts, just like we saw in that picture with the congruence earlier. So if I'm going to show the midpoint in this picture, I'm going to find where the middle is, put capital M to show that that's the midpoint, and then put hash marks to show that segment AM is congruent to segment MB. Remember how we show that: segment AM is congruent to segment MB. Similarly, we have segment bisectors. Now, this is very much like a midpoint, except it doesn't have to be just a point. It could be a point, it could be a ray, it could be a line, it could be another segment. It could even be a plane. It could be any of these things, as long as what it's doing is intersecting the segment at its midpoint. The segment bisector intersects the segment at its midpoint. That's what a segment bisector does. What it is any of these things. That's very much like a midpoint, except a midpoint is just a point. So we start drawing the segment bisector by showing the midpoint. Let's call it M for midpoint. From there, we can draw anything we want. We can leave it as a point. Maybe we want to show a line. If I show a line, I'm going to want to know how to label that. So I'm going to show another point on that line so that I can name the line later. Then I'm going to put hash marks to show that half of the segment is congruent to that half of the segment. And I'm going to describe this as saying line MC bisects segment AB. Now it's your turn to think a little bit about when in your everyday life, would you need to calculate midpoint? Can you think of a time where you'd want to know what is the middle of the 2 points that I'm exploring? Think about a scenario, think about a situation, and write an example for when you would need to calculate the midpoint. Go ahead and pause the video and do that now. Now this part that we're going to talk about is not in your printed notes, so go ahead and just watch and listen for a bit. We're going to find the midpoints between A and B on each number line. We're going to label it as M on each number line. Go ahead and ask yourself, where do you think I should be labeling M on this number line? Did you find it? Maybe you did it this way. I'm going to count how far, 1, 2, 3, 4, 5, 6. It looks like I'm counting 6 units away. So where would the midpoint, we could think of it as the middle, where would that be? Well, halfway is only 1, 2, 3 units away. So maybe I'm going to count and stop at this point, and I'll label it M right here. That's the midpoint. Let's look at the other number line, the one that's vertical, going up and down. Can you spot the midpoint here? What did you do this time? 1, 2, 3, 4, 5, 6. So again, that was 6. And maybe we counted how many spaces from the top? Halfway. And we landed here, only 3 spaces away, and we can put M, the midpoint, there. Did you do it that way, or did you think of a different way? Maybe there's a faster way to do it. I'd like you to try to take a moment, pause the video, and use the margin of your notes to describe another way you can find the midpoint between 2 points. Go ahead, we'll wait for you. Did you think of another way? Did you think of a faster way? Maybe you thought of this. At one endpoint, that number says -2. At the other endpoint, that number says 4. How do we find the middle between those 2 points? Maybe average? What does that mean? We take the 2 numbers, -2 plus 4. We have 2 of them, so we divide by 2. That makes 2 divided by 2, or 1. Well, notice where our midpoint landed. It landed at 1. What about over here? Point A is at 9. Point B is at 3. 9 plus 3 divided by 2. 9 plus 3 is 12, and 12 divided by 2 is 6. Well, where did our midpoint land? That's right, it landed at 6. Did you think of that, or did you think of another way? Now let's use that to find midpoint in a coordinate plane. Let's do this example together. Find the midpoint of the segment with these endpoints. Let's plot these first. Now I gave you a chance to make your own coordinate axes. Looking at these numbers, they're all positive. So I'm going to put my y-axis way over here because I don't need any negative space. And I'm going to put my x-axis way down here because I don't need any negative space. And then I'm going to plot these points. C is 6, 1. So I'm going to find 1, 2, 3, 4, 5, 6 and go up 1. And I'm going to write the letter C next to it. And D is 2, 9. So from the origin, I'm going to count 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put a D next to it. And now I'm going to connect those 2 points with my segment. So now remember, my goal is to find the midpoint. I could count like we did in the other ones. Maybe we'll try it that way. How far from D do I have to count to get to C? Now remember, I can only count up and down and left and right. I can't count across the blocks where the grid lines aren't going. So I'm going to count from D. 1, 2, 3, 4, 5, 6, 7, 8. I counted 8 spaces away. Half of that is only going 4 spaces. So I'm going to count instead 1, 2, 3, 4. 4 spaces and stop there. How many spaces do I have to go from the bottom over. 1, 2, 3, 4 spaces. Well, half of 4 is 2. So from here, I'm going to count 1, 2. And there's where I land, so that should be my midpoint. Let's find the coordinates by counting from the origin. From the origin, I count 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So this is at the point 4, 5, and we'll label that M for the midpoint. Now, if we're only counting in a small graph, it's not a big deal, but we don't always have the option to use small numbers. Sometimes the numbers are really big. So maybe we try it the quicker way, and that's by using the midpoint formula or by using the averages like we looked at before. So let's write down the midpoint formula or the averages of the x and the y's. So we're finding a point. Remember, midpoint. What does a point look like? There are parentheses, and there's a comma between the two coordinates. Now for finding averages, that means we're taking the x's. This is our first point, so I'm going to call this x1. This is our second point, so I'm going to call this x2. So I'm going to take those x's, x1 and x2, and add them. Averaging two numbers means I then divide by 2. Then I'm going to take the y's, y from the first point and y from the second point, and average them. y1 plus y2 divided by 2. Now this is a really useful formula, so let's note by maybe starring it or putting it in a box or highlighting it that we really need to know it. This is a really, really important formula. Now let's look at how we can use it to calculate this midpoint. So here are our 2 points. I'm going to start with the x's, and I'm going to show my ordered pair and put the x's 6 and 2 in for the x's, show divided by 2. Then I'm going to take the y's, 1 and 9, 1 plus 9, and divide by 2. Now let's calculate. 6 plus 2 is 8. Don't forget the divided by 2 part. 1 plus 9 is 10, and don't forget the divided by 2 part. Don't forget our parentheses because that makes it an ordered pair. 8 divided by 2 is 4, and 10 divided by 2 is 5. Let's write an M next to it because that's our midpoint, and now we're all done. See how that can be easier without having to draw a graph or count on a graph? So now let's look at an example where we're given the midpoint. Here's the midpoint of JK. It's this. One endpoint is J01. What is the other endpoint, K? The other endpoint now is what we're looking for. Let's look at a picture of this situation. Again, I only have positive numbers, so I probably don't need much in the way of the negative part of the graph. So I'll put my y-axis here and my x-axis here. And then let's plot our points. M is 4, 2. So from the origin, 1, 2, 3, 4, and then 1, 2. Put M there. J is the ordered pair 0, 1. From the origin, count over 0 and up 1, and put J there. Now remember that we're looking for the other endpoint, not the midpoint. The other endpoint is what we want. So this right here, M, this is the middle. M is the midpoint, the middle. So if I'm drawing my segment, it would go through the midpoint and keep going and end up somewhere around here. Now I'm not sure where yet, but it's somewhere around there. Now remember the 2 ways that we did the other problems where we counted? We could do that here too. To go from J to M, I count up 1 block and then over 1, 2, 3, 4 blocks. Well, if this is right in the middle, it means that the 2 halves have to be congruent. So I could count again up 1 block and then over 1, 2, 3, 4 blocks and find my endpoint that way. And there's K. But again, we don't always have the opportunity to make a graph or count in a graph. So what's an easier, more accessible way to find the other endpoint? Well, remember our formula. Our formula is x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. That equals our midpoint. Well, we have the midpoint and we have one endpoint. This is like our x1 and our y1. K is like our x2 and our y2 that we don't know. So I could take one of the x's that I do know and one of the x's that I don't know and add those together, 0 plus x. I have to divide by 2 always because I'm averaging, and that will equal the x from my midpoint, equals 4. And I could do something similar with the y's. Take the y that I do know and the y that I don't know, and that equals the y from my midpoint. So 1 plus y divided by 2 equals the 2 from my midpoint. And then solve those equations. How do we solve them? Well, if I want to get x by itself and I'm dividing by 2, the opposite is times 2. Do it to both sides. What's left over? 0 plus x. 4 times 2 is 8. 0 plus x makes just x, so x equals 8. Let's look at the other equation. Again, I'm dividing by 2, so the opposite is to say times 2, and do it on both sides. What's left over on the left? 1 plus y, and on the right, 2 times 2 is 4. This time we need to get rid of the 1 that's added, so subtract it from both sides, and y equals 3. So my final answer for my midpoint is 8, 3. Is that where we found it by counting? Let's look. From the origin, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Yep, point K is 8, 3. And I just noticed I called that point M. Silly, M was already given to me. This is point K. Let's fix that. This is the other endpoint, point K, 8, 3. Fabulous.